is causing from 30 winds increasing from 50 up to 65 knots. And 40 miles from the center. The forecast positions and
apart from equatorial regions, hardly any part of the world's oceans is immune from severe weather. Two of the world's busiest regions for tropical cyclones are the western South Pacific and the waters off northwestern Australia. Down south, mid and high latitude cyclones can affect vast areas of ocean. And in the Tasman Sea, the fronts swinging north are notorious for their explosive power, particularly when the colder air interacts with warm, moist air from the tropics. Even large ships work hard to avoid severe weather, because nothing is immune to the damaging power of nature. For small vessels, missing these adverse weather conditions is far more important, but margins for error are smaller, and the consequences of getting it wrong can be devastating. The power of severe storms is almost impossible to grasp without actually experiencing them. Severe storms at sea endanger vessels in a number of ways. The wind creates sea and swell of extravagant size. Oil rigs with platforms 25 metres above sea level have had their undersides badly damaged by impact. Naval fleets have been torn apart. As well as taking direct damage, vessels have been sunk when unsecured gear, and trawl booms are a favourite, has broken adrift. Wind lifts spray in such quantities to make a zone a metre or more deep which is neither sea nor air. Spray and the staggeringly dense rain makes a water blaster intense enough to rip off radar scanners, GPS antennae and even whip aerials. The most devastating effect of all for low-lying coastal areas and vessels sheltering there can be the rise in sea level caused by the cyclone, the storm surge. The extreme low air pressure within cyclones allows high tides to climb well above their predicted heights. It also lifts a plateau of water within itself that moves along with the cyclone. The bubble of water can be several metres high when it hits the shore. The banking up of water by onshore winds can be even worse than the bubble. Just the possibility of being exposed to this kind of uncontrollable power is reason enough to learn the behaviour of severe weather patterns, what is available for their prediction, and how to plan to avoid them. The Southwest Pacific, the Timor Sea and Western Australia average 14 tropical cyclones a year, about 18% of the world's total. Tropical cyclones are born in heat and humidity, so although they can form at any time of the year, the hotter months, from November to April, are usually taken as the likely cyclone season. Cyclones typically form between 5 and 15 degrees south. The weather event will start as a tropical depression, and it may or may not develop into a severe cyclone. On the surface, winds spiral in towards the eye in a clockwise direction, forming an intense near-circular vortex. Bands of convective clouds spiral in too and are a feature of cyclone radar pictures. Beyond the edge of the storm, the air settles gently, balancing the updrafts within the storm. This accounts for the unnaturally calm weather often experienced before a cyclone. The life cycle of a cyclone is usually about 9 days, but some survive for over 20 days. Some take days to mature, developing gradually in intensity, and others explode to maturity in under 48 hours. Speed of advance can vary constantly, and although a typical speed might be around 10 knots, the cyclone may stop, and they usually develop in intensity when this happens, or they could accelerate to 20 or more knots. To sum up, cyclones are erratic and unpredictable. Any plans we make must take account of this. The Bureau of Meteorology broadcasts marine weather from transmitters at Charleville in Queensland and Wiluna in Western Australia. Weather forecasts are broadcast every 4 hours and warnings every hour. Times and frequencies can be found on the Bureau's website. Broadcast times are given in UTC, formerly known as GMT. It's Eastern Standard Time minus 10 hours or Western Standard Time minus 8 hours. Write these times and frequencies into your contingency plan and also have a copy alongside your radio. The Bureau has introduced the terms storm force and hurricane force to describe wind conditions during extreme weather events. Storm force describes winds between 48 and 63 knots, with seas between 8 and 11 metres. Hurricane force describes wind in excess of 64 knots and seas with a probable wave height of more than 11 metres. Be aware, wind gusts can be a further 40% stronger than the average, and maximum waves may be up to twice the predicted height. It's very difficult to get everything right in an emergency. Contingency plans made in a calm atmosphere are essential. Dayboats have struck big problems when weather would not let them back into their anchorages. These boats are trying dangerously hard to get back in through breaking seas because the next accessible shelter is many hours away upwind. They had no plan to cope with weather beyond the ordinary. Boats working in areas subject to seasonal or periodic severe weather need a plan to follow when these weather episodes hit. The first choice of a small vessel will nearly always be to seek shelter. The plan should identify suitable places to shelter, which could be official ports or protected natural locations. On some coasts, suitable places to beach the boat should be identified. Ports and boat harbours will have contingency plans of their own. Get copies of these and make sure the vessel's plan fits in.
Make sure you've got some good strong springers as well, as indicated on that plan there.
There could be names, telephone numbers, radio frequencies and skeds to include in the vessel plan. Unofficial havens will need some research, good information from locals or actual visits to determine access at different stages of the tide, holding of the seabed and shelter from various directions. It's better to be on a mooring or lying to anchor with all cable out in a sheltered anchorage. Extra large-scale charts may be needed to get into these places, and perhaps notes from the pilot book. Establish the routine of always listening. List the frequencies and times on which forecasts are broadcast. On first warning of an actual or developing cyclone, start plotting. This will need small-scale charts of the region or a dedicated plotting chart, preferably both. Maintain a more frequent sched during severe weather. Talk to the coast radio station. Don't stay anonymous in severe weather. If the vessel has entered the OSREP system, don't forget to send a deviation report if forced to divert. To be secured in a haven with a 24-hour barrier between vessel and storm is a typical aim. Continually plotting the vessels and the storm's position will give the indication on when and where to seek shelter. Make allowances for changes in direction and speed of the storm. At the first warning of the storm, brief the crew, who should already be familiar with the contingency plan. Now is the time to bring out the preparation checklist.
Cyclone preparation checklist. You can grab one each.
From the first advice of the development of a tropical low, start plotting its progress. Nothing beats the graphic display of a cyclone advancing across a chart. The position given by the Met Bureau by international convention does not use degrees and minutes. It uses degrees and decimals of a degree. On average, destructive winds extend to a 90-mile radius beyond the centre. When predicting movement of the cyclone, the Bureau's positions should be accurate to within 50 miles for 12 hours and 100 miles for 24 hours. It's especially important to know where the cyclone is likely to be in a day's time. Firstly, plot the predicted position for 24 hours. Allow for the degree of accuracy of the prediction and the area of destructive winds. A circle of radius 200 miles gives the probable limits of the cyclone's effects. Combine this with a plot of the vessel's expected 24-hour position, and there is a near concrete basis for medium and short-range plans. The decision now could be to seek the nearest shelter, to maintain the course, or to turn around and run for the down-weather shelter. Wildlife are better attuned to nature than humans and sense the approach of a cyclone. Clouds of seabirds may appear chasing fish driven ahead of the storm. Others may be upset around their nests. The signs of the storm itself are classic. Unnaturally calm sea, oppressive atmosphere, and lurid sky are common. When the storm is several hundred miles away, long and heavy swell can indicate its direction. The swell runs directly from it. But this is not infallible because shallows between the vessel and the storm can intercept the swell. As the storm closes, banded cloud may appear, the troughs between clouds pointing the way to the storm. The barometer is not a good indicator. 100 miles from the cyclone's centre, it could still be reading nearly 1,000. The wind will rise well before the barometer plummets, and one of the hardest things to accept is that the wind is not coming directly from the storm centre. To get the approximate direction of the centre, face the true wind. The centre is on your left, somewhere between 90 degrees and 110 degrees from the direction your eyes are looking. If caught at sea, planning the best course to escape the storm centre needs considerations of the concepts of navigable and dangerous semicircles. The left half of the cyclone, its own left based on its direction of advance, is called the dangerous semicircle, and the forward quarter circle on that side is called the dangerous quadrant, the worst part of a cyclone to be caught in. A vessel caught here faces especially strong winds because the speed of advance is added on to the wind speed, and the natural action of the wind is to push the vessel into the cyclone's path. To tell which semicircle the vessel is in, hold a steady compass course and observe the change in direction of the wind over time. If it backs, changes in an anti-clockwise direction, it indicates the dangerous semicircle. If it veers, changes clockwise, it indicates the navigable semicircle. If it does not change at all, the vessel may be steering directly towards the cyclone. Use these indications to take the vessel away from the eye. In the dangerous semicircle, put the wind on the port bow and keep it there. In the navigable semicircle, put it on the port quarter. Evading a cyclone at sea is nearly always second best to being safely secured in shelter. The trawler Simon K is on passage along Australia's northwest coast. It's cyclone season, so the skipper has checked his contingency plan and has identified refuges along his track.
Tropical cyclone Frank with central pressure 980 hectopascals, located within 20 nautical miles, latitude 14.8 degrees south, longitude 117.0 degrees.
The skipper plots the estimated position of the cyclone, remembering that positions are given in degrees and decimals of a degree. The expression UTC means the same as the old GMT. He compares this with his present position and predicted position for 24 hours' time. At this stage, he believes the cyclone is distant enough for him to retain all options. Rather than returning to Onslow, he feels justified in maintaining his course, with the next port of refuge being Dampier.
Good afternoon. High seas weather warning for Met Area 10, issued by the Bureau of Meteorology.
Subsequent updates do nothing to change his opinion.
Cyclone warning for severe tropical cyclone Frank. Central pressure 960 hectopascals. Located near latitude 18.0 degrees south. Longitude 116.0 degrees east. Moving south at 25 knots.
The cyclone has tripled in speed and turned south. Using the 200-mile radius circle around the predicted 24-hour position of the cyclone, the skipper decides that Dampier is no longer possible.
Learmonth Base, Learmonth Base, Learmonth Base. This is Simon K. Simon K. You there, Jim?
Simon K. Simon K. Simon K. This is Learmonth Base.
Yeah, roger, mate. Listen, this cyclone's changed course. And it's speeding up. It's heading straight for us. We've made the decision to more or less head straight for the Fortescue River, and we'll put it up into the mangroves there. We'll have near on high water when we get there, so we should be right, mate. So once we're secure, I'll give you a call, over.
Yeah, roger. Got you there. All the best for now. Standing by. Over and out.
The crew, meanwhile, are preparing the vessel for heavy weather. The aim is to take the vessel to shelter, but preparations are similar for a vessel encountering severe weather at sea. Portable things on deck, such as nets, are taken below and secured. Heavy items like booms and boards are secured against movement. Things below decks too are secured. Ways for water getting inboard are reduced by bagging or plugging. Glass is protected, and food is made ready ahead of time. Increasing stability by reducing the number of slack tanks is basic, as is reducing top weight. Draining the brine tank achieves this. Later in the mangroves, the tank can be refilled to ballast the vessel onto the bottom. Unused aerials such as UHF and VHF can be taken down. Simon K.'s skipper has chosen to put the life raft in the wheelhouse, where it can't be blown away or accidentally hydrostatically released. The skipper has checked the tide tables for access to the mangroves and intends grounding the vessel. The vessel is aground, but the engine continues slowly ahead to help maintain position. The keel cooler allows this without overheating. All available wires and ropes are secured to the strongest anchor points available.
We're in the mangroves, everything's secure. Barometer's starting to fall quite rapidly now, and we're getting a bit of cloud formation. Swell's starting to pick up and the wind's definitely increasing. Our position is 21 degrees south, 116 degrees 7 minutes east. Did you get that, over?
Yeah, roger, roger. Okay, all the best for now, and hope everything goes well. So I'll catch you later on. Over for now.
And the crew gather in the accommodation to sit it out. Havens of opportunity like mangroves are always second best to cyclone moorings or berths in marinas or alongside, if only because the crew can take shelter ashore. To sum up, plenty of lines out, stow or unload, secure, make watertight, and then get off. Severe weather at sea is a fact of life. The crucial steps in coming to terms with it are planning and preparation.